So it started first time that time, but it's unreliable, so for the price it was just worth replacing. Ah, the heck, I was bugging, I was messing about, sorry folks, I was spending ages and ages to get this set up. We got time. Right, hello there, hi, how are you doing? I just little out of bed and I came up with an idea for the video. So in a wee bit out of disoriented, still kind of waking it up. I've got my coffee just to kind of try and waken us up more. I've kind of like limited for time, so as usual I just wing it. If you know my videos, you know what I'm like. Anyway, it's about a washing machine pump. This is what's responsible for draining the water from the automatic front loader washing machines. Now, I'm going to show you how it actually, what it looks like when it's switched on as a unit. So do not do this at home. It's extremely dangerous. There's live wires involved because it works directly off the mains. So do not do this at home unless you're a qualified electrician. Now, I'm going to go through some of the parts of the pump, but before that I'll kind of like try and do a reintroduction. That was a bit shit to start with. Anyway, this you might know, you'll see this more in my videos, this new hat of mine. It's quite good. I got it from the Edinburgh market. It's a nice wool one. It's really comfortable. It changes the colour. I'll show you what it looks like when because all you do is just put it inside up. Just like that. So you can have it the colour it was before and you can have it this colour. And then it's got these to keep it down, keeps my ears warm. So I thought I'd show that off because I got this just very recently and you'll be seeing that in my videos. I've tried to get something like this before online. The problem with buying stuff online is that you don't get a chance to wear it first, and when it arrives, it's not necessarily what you think it will be like. But I was in Edinburgh Market, the Edinburgh Christmas Market, at Edinburgh's Princess Street Gardens, and I saw lots of shops, including the shop that I got this from, and I was able to wear it in, it was actually a stall, because it's all stalls, temporary shops. So I was able to wear it on and it felt the way I wanted it to, and I was able to see it in the material as opposed to online. So I was quite happy with that. I bought that right there and then. So I said that'll be ideal for keeping warm, keeping them down, keep the ears covered, and I like the shape of it and like the design, so I'll be wearing it in my videos. So I thought I'd introduce that. This video, by the way, if you know my videos, it's I had a plan A. It wasn't going to work, so I resort to plan B. I just make it up as I go along and I wing it. For those that are familiar with my videos will probably know that by now. So I was messing about with all the things. It kept falling over, I kept doing this, I'd run out of time, so come on, I'll just start it. Anyway, back to the main subject. There's a couple of points I'd like to make in this video regarding the automatic washing machines. Some of the, well, a particular failure point that is worth mentioning, I think, for those that would be qualified to open up the machines and work on them, or those that have the electrical knowledge and safety aspects of it. I wouldn't not, and in fact, to make it clear, do not open up a washing machine or any electrical appliances that operate on the mains voltage unless you are a qualified electrician and know what you're doing. Don't do that. Just don't open it up, because there's a lot of high voltages and moving parts and all sorts of hazards in there. But I've got footage that I could show people that understand about all these things, you know, that are qualified, etc. And I'm going to highlight a couple of fail points that I spotted because I was watching the washing machine with the top cover off and the back cover off, and that basically exposes the internal workings of the automatic front loader washing machine. Your typical washing machine, basically. Most of them nowadays are. As opposed to the older ones where you had the top loader, where you would actually do it manually. A manual washing machine. Well, my auntie had one years ago. But this is the automatic ones that you're probably most familiar with. So I'm going to try and keep this video short. The pump, as I say, that's responsible for draining the water from the drum. It's gravity fed. Water comes from the drum, comes in through this gland. There is a filter. Now, you would obviously make sure it's drained because these things tend to hold water and hold on to water even though it's taken out the unit. So it goes through the gland from the drain, gravity fed, through this filter which catches big objects like socks and hankies or anything. It acts as a screen basically. And then it goes through this impeller, which is connected directly to this shaded pole or 2-pole motor. I'm not quite sure the exact term, but it's a very basic motor. I think it's synchronised off the mains voltage or something. My dad knows all the terms and all the technical stuff because he is a qualified electrician. But anyway, it's just basically that's your main motor component there. The coils are in there. I thought it was a permanent magnet motor, but anyway, going to the basics of it. The water comes down here, gravity fed through this gland, past the filter to catch any debris. The pump displaces the water out from this gland and then up through the pipes and into the drains. There is an overflow gland as well. So if you need to drain the pump or drain the washing machine with no power, you would go to the front panel of the washing machine, and there's a bit where you could actually, a pipe that's connected to this where you could drain the water from the drum. It's gravity fed, but you need a bucket or a pan or something because it will be low down to the floor, being gravity fed. The pumps, it doesn't compress water. You can't compress liquids. It only displaces liquids. So when the water from the gallons of, I don't know the quantity, but the water from the drum is being displaced, the weight of the water is going down into the glands, through the filter. The impeller spins, and then it causes the displacement of the water to come up this gland through the pipes and into your drainage system. But it comes a point where it's emptied, the drum's empty, but there will still be water at this part of the system that the pump can't push out because there's nothing. It can't use the air to push the water up. It needs water behind it in order to push the water through. So it's a continuous loop. But by this point, the drum's empty anyway. But there's always water in there to keep the bearings in the pump from seizing up because it's lubricated with it. I'll show the failure point with it as well, why we had to replace it 3 times on our washing machine. And there's another thing that I'm going to put up. In fact, while I'm doing this intro, I'll explain a bit about it, because then I could remember to put the little caption up there on the screen, because I took it from the other device. It's basically the inner drum and outer. You've got the drum. Your washing machine's got, you open the door at the front, you put your clothes in, right? That's the inner drum, the silver bit, the stainless steel part with all the holes, that's the inner drum. Then you have an outer drum that you don't see unless you take the top cover off. That basically is where everything is, all the water and everything is kept within the outer drum. At the bottom of the outer drum you've got your heating element, the actual heating element to heat the water up to the desired temperature. Now the outer drum at the back is what supports the inner drum. You've got a main, well there's only one support, and it's in the form of a bearing. So there's one main bearing at the back of the inner drum that connects to the outer drum, and then the other side you've got the spindle where the belt, if it's a belt driven washing machine, because you get direct drive washing machines these days as well, but this is the belt driven one, the old conventional one. So at the back of the drum you've got a spindle where the belt goes on and connects to the motor, which is at the bottom. It's at the bottom, somewhere at the top, but it's to counterbalance anyway. You've got weights at the top of the outer drum, and you've got weights to counterbalance the movement. So the inner drum spins within the outer drum. All the water's contained within the outer drum. All your pipes that connect to the drum are connected via the outer drum, and the holes in the inner drum allow the water to go in and the water to escape as well. So the outer drum is suspended from the chassis of the washing machine. That's the main bodywork of the washing machine. So everything, the outer drum is, you've got a spring on this side, a spring on that side, and there's a 20th of December 2024. And that's the primary reason I think it's serious fault there. In fact, collapses, that's it. It's just due to the composite inner drum. It's just composite material, soft, so it's cutting through it. Hook on the outside of the outer drum on each side for the springs to hold onto. So the other end of the springs hold it to the actual bodywork of the washing machine, and the opposite end is suspending the outer drum, this side and the opposite side, and there's hooks. Now the old drums used to be made of metal, the water drums, But this one is made of composite, like a plastic material. So through time it's wearing out. It's a softer material than metal. So as I say, the outer drum is suspended by two springs, on one on that side, one on the opposite side. Then at the bottom of the outer drum you've got shock absorbers that absorb the shock, basically. So when it springs about, without shock absorbers it'll just keep springing about, oscillating. So that controls that movement. So you get some movement, but it dampens it, it limits the movement. And it supports the drum at the bottom as well, so it doesn't wobble about. It needs some form of support. But the main problem with this, the problem I'm going to highlight, as you hopefully see if I've got it correctly, is that because I've got to sync it up when I compare this video, it's the actual weight of where the spring meets the outer drum. There's a hook for the spring to go into. Well, through time it's basically elongated the hole where the spring goes to, so it's just basically going to eventually come right through. Because the plastic composite material is it's soft, it's too soft, because through time the weight of it's just being suspended by springs. So on this side and other side as well, it's starting to wear. It's causing, just through time, for the spring to eat through the composite material, so it's no longer going to support. So eventually it's just going to go like that, and the drum's going to drop down at that side, and you've got a water seal at the front of the drum which might get torn in the process, which would obviously allow the water to come out and flood the kitchen, which would be a disaster. And it could short circuit as well, water's going everywhere. So I spotted this fault developing. It's just about at the point where it's going to actually fail, so we'll have to ASAP get something ordered up soon. I happened to notice it just during looking at the operation of the machine with the top cover off, because I'm quite interested in that. You never do that, by the way, unless you know exactly what you're doing, unless you're a qualified electrician. Do not open any of these covers and switch it on when there's power going into it, because you must be fully aware. I'm going to pause this a moment, sorry. So I'm going to show you this closer up, and then I'm going to switch power on to it. Now this is not how it's installed in the washing machine. This setup was done with someone that knows all about the safety of electricity. So you do not do this at home unless you're, as I say, if you're the qualified electrician and you know exactly what you're doing, just don't do it, because these voltages are deadly. If you get a belt off one of them, it could kill you quite easily. So that's why you don't want to do anything like this unless you know exactly what you're doing. A wee closer up look at the thing, the design. This whole housing here comes off. It actually unscrews off, which I might even show you that. So that's the front cover off, and then the front cover, the front water housing bit off. That just basically turns clockwise onto there to keep it from coming off. There's these, you just basically twist it, line them up with the pegs and twist it round, and then it locks it in, because these pegs there go between, or go behind the pegs on this housing. So it's just basically, you just line them up and you twist it. I can't really demonstrate well because I'm holding this camera at this side, holding it on the other, but it goes on like that, and then you would just twist it till these lugs go under there. That's all. There's no any tools required to remove the water housing. This is the actual housing, and then you've got the filter that's the bit that's on the front of the washing machine. Yeah, you could access this filter from the front, the bottom lower panel, the lower valance panel on the washing machine. So that's what you do. You just keep screwing that until it bottoms out. It'll stop turning because it'll reach a stop there. But I'm not going to do that now because I need two hands to do that. So I'm holding the camera with the other one. This is the pump impeller. Now this failed because water got past the back of this impeller and it got into the actual inner parts of this motor, because all this was full of water, and it caused problems. So it started to intermittently had problems starting up. Now this happened on the previous pump as well, so that's a failure point. But it does work when you plug it into the mains when it's connected up as a component like this, but it won't work in operation when it's in the machine very well. It's unreliable, because when it was not pumping the water out at times, obviously that's a real problem during the wash cycle. But this bit here, with the shaft goes in, this was all full of water. Now I know it's lubricated. There is some form of lubrication. I don't fully know where all the parts, how it does it like, but I remember being told that it needs to be water in the pump system all times basically when it's installed in the machine, because you don't want to run this dry. If you run it like this dry without water, it's going to overheat apparently. So I'm not sure exactly how the water lubricates it, unless it's going to be sealed. But anyway, I was told that it needs to have water in this system all the time. So that's why there's always amount of water. There's always so much water after the outlet gland to the pipe, you know, because it's at the bottom of the washing machine. It's got to be gravity fed. The pump's responsible for lifting it up to the drainage. If you plumb it in, it's got to lift the water up to the actual drain gland in your kitchen sink. But once the pump stops working, or even when the pump's turning and there's no water behind it to push the water forward, it's just going to keep water up to, from the pump to the bottom of the kitchen sink gland. So there's still water sitting in the pump system, which keeps it cool and lubricated, I believe. So anyway, this one failed because it was excessive water then that got into this part of the pump at the back, and it makes a heck of a noise when you switch it on, as you're going to hear very shortly. And in the kitchen, just to show you what the other washing machine looks like, it's this one here. Now I've done videos on this one before, but I'm going to try and keep this video short, so I'm just briefly showing you it. If I remember, I'll stick a link in the description to this video where you can see my washing machine working with the top cover off and the back cover off while it's been in use, and you'll get to see all the parts moving, the pump, not the pump, you'll get to see the motor, the belt and the pulley and everything working. You'll get to hear the pump and see the suspension springs working as well. So if I remember, I'll stick a link in the description to this video. If I don't, it's called Washing Machine Working with Top and Back Covers Removed, and it's on my channel. So I'm now going to wait to switch it on to the main socket, which, as I say, I have to keep saying it, just don't do it at home. It is, I'm being serious, it's deadly voltages and that, so just, this video is only for viewing and entertainment purposes only. It's not for anything other than that, it's just for viewing and entertainment purposes only. Okay, so I'm going to switch it on and show you this working. Now it's hooked up to the mains. I'll show it with the housing removed at the front. Now, here it goes. It's going to start jumping. It's going to make a noise that it shouldn't do because that's due to the fault. Right, here it goes. Now I know the bits to hold and what bits not to hold. No, it shouldn't jump about like that to start with. Now I'd love it if I had hoses to actually demonstrate it pumping water out from 2 buckets. Now I haven't got around to doing that. It was about 20 years ago, back in 2003, right? My dad was working on an old machine here, and I was able to use water, 2 buckets, to demonstrate the pump actually working. I was wanting to see it working, so you know, I was just letting them know I was still filming. And, yeah, 2003 I was able to actually show the, well, I wasn't doing YouTube, I didn't have a camera like video recorder back then, but I was showing myself, my dad, my brother, hang on. Yeah, so I was showing that working. Maybe in the future, if I come up with an idea, I could do another video when I'm actually showing that pump working with water. But again, you've got to be careful with the mains voltage and water and everything. But if I could get around to organising it, arranging it to be done safely, obviously, then I could do a video in the future. So you just keep checking my channel and you can actually see this pump working, actually demonstrating moving water. And with its primary functions about. Put the housing back on and I'll show you what it looks like with the housing on. So the housing, you could change the orientation with the housing as well, depending on what way you line it up for different applications and different washing machine models, because this will be a fairly standard pump model. So this is it on now. Let's switch it on. And you'll see the impeller. In fact, what I'll do is I'll pause. Right, here it goes. And you see it jumping about a bit there, that's due to the fault. So when it was starting up, when the washing machine gave it the command to switch on to empty the drum, it would start up. Sometimes it wouldn't start up, it would just make that noise and then it would fail to start. And then of course it wouldn't empty the water, and that causes problems during the wash cycle. See, it shouldn't jump around like that. See that? And then it started. So it would sometimes it would just keep making that noise. That's no use for being when it's actually installed in a washing machine. That's not any good. So that's why it needed to be replaced. The filter on, that's switched off at the socket. You just turn this. I can't really do it at the same time, but that just screws in clockwise. I've slackened it off just to demonstrate. So it's anti-clockwise to remove it. Okay, put it into the pump. So this would be done from the actual lower ballast on the washing machine. This is actually done from in there. So that panel comes off and you can recognise it. That's the drain hose that I was talking about earlier for manually draining the pump. That's the drain hose gland. Where the water will just be gravity fed. It'll just run out without any power applied. So I don't think every machine has this, but this model does anyway. The older ones didn't have it. You had to wait somehow. You had to let the drum cool down before you could open the door, and then it would drain out like that. The water would just come out everywhere. I remember that on my dad's old washing machine. But the modern ones, I think most of them, or certainly some of them, have this where you could just drain it from here. That's the filter that I was talking about. That just unscrews. That's accessed from the front, the lower ballast panel of the washing machine. And it's behind its cover. That's just for protective cover, just to hide it as well, for tidiness, to make it look nice. Anyway, where they are, the pump will always be at the bottom part of the washing machine. So, with the filter installed now, the power's off at the socket. Put my fingers anywhere near the wires. You won't really see anything unless you look down the gland, but here it is anyway. That's the outlet gland. The inlet gland is the bigger one, that sits at in front of the filter. The filter is in front of this, so you won't see the impeller, the pump impeller turning. You can hear how noisy that is. That's not right, you see? That's why I had problems with a drum emptying water, because it was doing this while it was installed in the machine. And sometimes it wouldn't clear. This is under no load. So when the pump was under load, it was just not doing the job properly at all. Now there's mains going to this, but I'm being very careful with touching. So as you can tell, the water comes out here, you can actually see the impeller. This is after the filter. The voltage bits is on here, that's the mains voltage. Now it's starting to show because I've moved it, unfortunately. That's live. I've dislodged the wire a bit there. Be exceedingly careful. You just treat everything as live if you're not sure, basically. In other words, don't touch anything if you're not sure. Just play it, I'll start it once more. So it started first time that time. But it's unreliable, so for the price it was just worth replacing. I've come up with any ideas on how to actually demonstrate it, lifting water, pumping water, displacing water from maybe one bucket to a higher bucket, you know, when it's higher up, so the pump access to pump the water up. Water will always run downwards through gravity. That's just the nature of gravity. It pulls water downhill. So everything's got to be, for it to be gravity fed, all the water's got to be above the pump. So the pump remains at the bottom. It's the water runs into the pump, through the pump, but it won't go up to your kitchen drain, sink, or the plumbing in method that you use. The drain hose has got to be above the drum of the washing machine. Otherwise the water will just run out the drum when it's filling up. So it's always, the drain has always got to be higher than the washing machine drum, so the water isn't gravity fed right out the drum. It would be hopeless if it'd be no use whatsoever. That's why the drain has got to be higher than the washing machine drum, otherwise the water will just run out during the wash cycle. And then when the washing machine brain, the timer, gives the command to the pump to start emptying the drum. That's why you need a pump to lift the water up to your drain, and it's just done through displacement, through the white impeller that you saw. It's connected directly to the motor of the electrical part of the pump. It's a fairly basic system, 2 wires. It doesn't have a speed controller. I think it's just in sync with the mains. So the mains voltage and the mains power is actually your speed controls. It's in synchronization with the mains voltage. Whereas the main primary mover for the washing machine drum is done through a speed controlled motor. Yeah, so the actual drum is turned with a motor. I can't remember, it has a speed controller circuit anyway. Basically, when you set the speed, or the settings, you've got the desired speed for the motor to turn it, either through the manually inputted from the machine operator, i.e. whoever switches on the washing machine, for your spin speed. And then you've got the desired setting from the built-in program for what speed the drum has to turn it. So when there's a load in the drum, when it spins, the clothes have been tumbling about the drum, at some point the clothes are going to be falling from the top of the drum to the bottom of the drum while it's being turned. So it's just falling through air, which will take load off the drum, which means the motor would speed up until the clothes hit the bottom of the drum, and then it will slow down again. So the motor will be going slow, fast, slow, fast, fast, slow, fast, slow, and everything. It will just be doing that, oscillating. I think some of the older washing machines done that. They didn't have speed controllers. It was, I can't remember what the term was called, induction motor or something. But the modern machines now, well, quite a lot, even the earlier modern machines, I think, were fitted with an electronic speed controller circuit, which basically monitors the speed, the desired speed that's been set, whether it's pre-programmed by the circuit boards or set manually with the controls at the front. So the speed controller monitors the speed of the motor. So when it goes under load, it'll compare the setting with the actual speed of the motor, and if it detects the motor going slower because it's under load, then it applies more power to the motor, and it does this electronically within a fraction of a second. You won't notice it, but the speed controller is always monitoring and correcting the speed of the motor to keep the speed of the motor at a steady, constant speed. So it's got to match the speed. So if it's set for speed X manually or pre-programmed, and it's maybe at speed V, it's a bit slower, it'll put more power in automatically to bring it up to speed X. So it's comparing the actual speed of the motor with the setting, the input setting, and if it needs more power, it gives it more power. If there's load off the motor, i.e. if the clothes are falling down in the drum, so there isn't any load on the drum, or less load on the drum, the motor would have a tendency to speed up. So therefore it notices it's speeding up, it'll take away power, it'll give it less power to keep the motor at a constant speed. So it's just regulating the voltage going to the motor, basically, to keep the speed of the motor the same when it's turning. So when it's turning clockwise, it's got to turn clockwise at the same speed, then it'll stop. Then it'll turn anti-clockwise at the same speed, then it'll stop, and it'll turn clockwise. But it turns all these speeds at a fixed speed due to the speed controller circuit. within the motor and within the actual washing machine bodywork, the casing of the machine. There's a monitoring speed control circuit on the motor and sends the signals up to the circuit board that is part of the speed controller circuit board, and it just regulates it that way. The pump, on the other hand, the drain pump, doesn't have a regular speed regulator on it. It just works through the mains. It's 50 Hz, I'm not quite sure. The signal, the actual frequency from the mains voltage, from the mains basically, it's a very basic motor. I think it was I can't remember. My dad told us it, shaded pole motor or something. I'd have to read up on that, I can't remember. I think it's a permanent magnet, because when you switch the motor off, you can see the way the impeller just stops. It's like it's magnetic. There has to be something to cause it to stop very quickly like that. So I tend to think there's like a magnet in there that would cause that. But it doesn't have a circuit board or anything to regulate the speed of the pump motor. And through the because it's more or less got one task to do, and it's just to displace water at a fixed height. So all it does is it has two loads really. It has a near empty load. When there's water, it's actually just sitting in against the impeller between that and the drain, so it's not really got much load. And then it's got, I suppose it'd be that or a full load where the water's draining from the drum through the filter, and then it's required to get pushed up through the outlet gland, and it's got to go upwards to overcome gravity. So there's a typical plumbing in system. This is the drain hose, so this has got to be higher than this point here. Has got to be higher than the drum in the washing machine, otherwise it will, the water will just run out while it's in use. So the water won't run, when it's due to empty, it's not going to go up against gravity, therefore it requires a pump to pump the water up to this point and then into the drains, and then it will drain outside. So it goes through your normal drain, which is under the kitchen sink. And actually hear the water gurgling. If you put the light on, you can actually, when the pump's in operation, you can see the water below this. Well, this has been cleaned recently, but the drains are cleaned outside, so that it used to be that the water would come up a wee bit and then it would drop down. But now that the outside drain's been cleaned, it was desperately needing cleaned, I might add. You could see the water just coming in from the gland underneath here. You can see it spinning round because it's hitting the wall and it's vortexing, and then it's dropping down into the drain. The drum, as I say, this is the inner drum. It's supported with the main bearing at the back. The outer drum is behind this. It's with the heating elements here, and all these holes is obviously for letting water in and letting water escape. And the inner drum, the outer drum is suspended with the suspensions. There's two springs that are on each side there that supports all this. And as I mentioned earlier, the soft composite material, plastic-like material, was just soft, and the spring where it's fixed onto the outer drum is just about on the verge of coming right through the hole. It's making the hole elongated. In other words, the hole's just starting to get, there's a hook, there's a bit there that's eating through it basically, and it'll just come to an open-ended bit, and then the drum will drop. And this seal here, this is the front seal, that's eventually just going to tear, because if this drops inside, the water could come out here and flood the kitchen. So it desperately needs replacing them. Right, so that's it. I'll hold the video off at that point. I think I've tried to show you and explain as best I can what I wanted to relay across in this video. I just wanted to put some of that information out there just to show those that are interested, like myself, and also those that are qualified, that could have some sort of understanding as to what's shown. I'm fascinated in these things. I always have since I was a kid. I used to watch my dad repair countless things during these days. Homers and repairs cars and washing machines. I was always interested and fascinated in it. You might know that from previous videos that I mentioned that. I felt as though I wanted to share this on my channel for those that are like myself, that wanted to maybe perhaps see what the washing machine pump looks like as a component and operating as a singular component when it's not installed in the washing machine. And as I say, if I get around to thinking or figuring out how to connect up some hoses to the pump, I would obviously need to drain off the drainage hole port, that gland, because the water will just run right out there. That'll have to be blocked. The other pump that I done it on in 2003, that hot point wash machine, that didn't have a drain gland. It was just it had the filter, I think. Yeah, I should have had that, but it didn't have the drain gland, so you had to actually wait on the thing cooling down before you could open the door. So if the drum didn't empty, you had to open the door and let the water run out that way. It was a messy job. You had loads of towels to put down to catch the water until you got a bucket or a tray or something. But they made it easier by putting a drain hole and drain tube at the bottom. So you need a flat tray to put there, because obviously you don't have much clearance between the ground, the floor and the bottom of the machine. So you need a flat tray to to gather the water, because you're talking a drum full. But it always falls out to so much in the drum, but the drum load's worth. So anyway, hope you enjoyed the video. See what else I put on my channel. I'll try and remember to add both links in the description, because I've done 2 videos. I've done a video with the top cover off, and I've done a video with the back cover and the top cover off regarding that washing machine while it was working. So if you want to see these videos as well that I made, then I'll do my best to remember to put the link in the description in this video. Okay, thanks for watching. It's coming up for Christmas, by the way, so if you're watching this before Christmas and now, then have a nice Christmas and Happy New Year. Bye.